Here we go again, a very clumsy review of numbers of the systemic circuit using the graffiti page as a reference point. Okay, here we go. Again, what we've done is used our icon or diagram to show the pulmonary and systemic circuit. So here's the left side of the heart pumping into the systemic circuit. Here's the right side of the heart pumping into the pulmonary circuit. Over here, pulmonary arteries, pulmonary capillaries, and pulmonary veins. Over here, systemic arteries, systemic capillaries, and systemic veins. Now, the majority of the numbers that we're going to offer here have to do with the systemic circuit because in clinical situations, these are the numbers that are easiest to get at because this represents things such as pulses in your arm, your wrist, in your femoral triangle, popliteal region, dorsalis pedis, carotid. All those kind of numbers are relatively easy to get in the systemic circuit, but in the pulmonary circuit, well, these things are found within the rib cage and therefore not readily available. So here we go. First, if I look at where the blood is located, approximately 18% of your total blood volume is found within the pulmonary circuit. Approximately 70% is found within the systemic circuit. So once again, obviously the systemic circuit is much larger than the pulmonary circuit. Even though the volume of blood is passing through is the same at any particular moment, only about 18% found in the pulmonary circuit, about 70% found in the systemic circuit. Now this, of course, means that 18 plus 70 is, 88, and so therefore there's 12% missing. Now these numbers are all relative numbers, and that 12% is found inside the chambers of the heart. So 6% in the left side of the heart and 6% in the right side of the heart because the chambers of the heart carry the same volume of blood. Even though pressures may be different, the volume is going to be the same. Now, looking here inside the systemic circuit of that 70% of the total amount of blood, approximately 10% is inside the systemic arteries, approximately 5% is inside the systemic capillaries, and 55% found within the systemic veins. So again, 10, 5, and 55, there's the 70%. Now the significance of these numbers right here is that there is a much larger volume found within the systemic veins than in the systemic arteries or even the capillaries. Because of this, later on we'll talk about something called a venous reserve, how the veins in essence can represent a supply of blood that can be pushed into circulation in the event of a need, such as in compensation for blood loss. More about that later. Okay, some other numbers that are significant around here. Let's look at speed. The speed of the blood inside the systemic arteries, for an approximation, is around 40 centimeters per second. Going through the systemic capillaries, 0.1 centimeters per second, and inside the systemic veins, 20 centimeters per second. So there's a drop from 40 to 0.1, and then it speeds up a little bit back to 20. All right, here's something else. The pressures. Near the heart, blood pressures are 120 over 80 for our cartoon person here. The high number here is the systolic pressure, the push of the left ventricle. The low number is the diastolic pressure, and that's how low the arterial pressure goes before the next surge of blood comes from the left ventricle. Now, with 120 over 80, the mean or average pressure is 93. Now, it's not the top number plus the bottom number divided by 2. There's a formula for it, but this right here represents the mean arterial pressure, 93. And later on, we'll find out that's a quick and easy number to sort of judge circulatory health. Another quick and easy number for judging circulatory health is this one right here. This is called the pulse pressure. The pulse pressure is the difference between the systolic and the diastolic pressure. So 120 minus 80, it's 40 right here. And this is, again, another indication of how well the circulatory system's working. Later on, we'll look at examples of how somebody can have a pulse pressure of 40 even though their systolic and diastolic numbers are pretty unusual. But the 40 says the system's functional, even though it may be a bit radical if this is very, very high or if they are both very, very low. All right, looking at a pressure going into a systemic capillary, these are very general numbers for the sake of starting a conversation. Consider there to be about 40 units of pressure going into a systemic capillary and 20 units of pressure coming out. Again, very relative numbers. So there is a steady drop from 120 down towards 40, then to 20. As we turn the corner and head back towards the right side of the heart, the pressure continues to drop. So it's going down towards 0. Now, the novel thing right here is the so-called average speed in the arteries was about 40 centimeters per second, and the capillaries 0.1 centimeter per second, and then the venous speed 20. Even though the blood pressure is dropping constantly, the speed of the blood inside the veins went up a little bit. It sort of picked back up a little bit. And that's something we're going to call laminar flow. We'll explain it later on. Another thing that's significant in this quick story is the speed of the blood going through the systemic capillaries is approximately 0.1 centimeter per second. However, if we change that over to millimeters per second, well, that'd be 1 millimeter per second. But then if we stop to consider that the average systemic capillary is approximately 1 millimeter long and about 8 micrometers or 8 to 10 micrometers wide, suddenly there's a lot of interesting stuff right here. For example, if the speed is 1 millimeter per second, the length is 1 millimeter, then that means that the blood moves through in 1 second. And dropping off of the oxygen and dropping off of the nutrients and electrolytes has to happen within 1 second. Within that same second, it has to pick up the carbon dioxide and pick up the waste. Also, the exchange of hormones and such also happen within that 1 second. The diameter of the average systemic capillary is about 8 to 10 micrometers, and that's significant because the diameter of a red blood cell is approximately 8 micrometers. So the red blood cells are just barely big enough to go through the capillaries. Now, the white blood cells very often are bigger than 8 micrometers, but white blood cells are not so rigid as the red blood cells. White blood cells can conform, they can deform, they can squish their way through. So, in reference to quick numbers around the system right here, that's what we're looking at.